Hello. So in this question, we need to fill up the table with pH or concentration of the acid, concentration of the base, or pOH, and determine if the solution in each row is acidic, basic, or neutral. So part A, you're given the concentration. So we can start by finding the pH because it's negative log concentration of the acid, which is negative log or 5.4 times 10 to the power minus 4. If you do your calculations, your pH will easily be found. I hope you know how to use a calculation. So the answer here, the pH will be 3.27. In fact, that's just 3.3. And then, so this is 3.3. So to find pOH, we know that pOH plus pH is equals to 14. So pOH is 14 minus pH, which is 14 minus 3.3. So your answer is 10.7. Is the solution basic or acidic? You see, based on the pH right here, you can tell that the pH is below 7. So we can say it's acidic. But before that, let's find concentration of OH. Now, the concentration of acid times the concentration of the base will always be equal to 1 times 10 to the power minus 14, which is kW, ionization of water. So if you want to find concentration of the base, is 1 times 10 to the power minus 14 divided by the acid concentration, which is given in the table. In this case, the acid concentration was 5.4 times 10 to the power minus 4. It's given in the table there in black, you see, it's right here. So pOH or OH minus is gonna be equal to, okay, so we will say 1 exponent minus 14 divided by 5.4 exponent minus 4. So I'm getting concentration of the base to be 1.85 times 10 to the power negative 11. So here it's 1.85 times 10 to the power negative 11. Okay. Now let's go to part B. Use blue. So for B, we are given concentration of the base. We know that the concentration of the base times concentration of the acid is 1 times 10 to the power minus 14. So I will need the concentration of the acid to find pH and also to fill this part here. So it will be 1 exponent minus 14 divided by concentration of the base, which is 1 times 10 to the power minus 14 divided by concentration of the base on part B is 7.8 exponent minus 10. Okay, so I'm getting the answer to be 1.28 times 10 to the power minus 5. So this is 1.28 times 10 to the power minus 5. And using this, I should be able to find pH. pH is negative log concentration of the acid. Okay, we just found the concentration of the acid. So I'll say negative log the answer. And I'm getting the pH to be 4.89 or 4.9. So pH is 4.9. Again, it's below pH 7. So this is acidic, and of course pOH is easy to find. pOH, that should be negative log concentration of the base. Negative log concentration of the base was given as 7.8 times 10 power minus 10. So we'll say negative log 7.8 exponent minus 10. I get it to be 9.1. The other way to get pOH, of course, it should be 14 minus pH. This is your pH. 14 minus 4.9, so it should still give you 9.1. So this is 9.1. Okay. Now the next one, part C, we are given pH equals to 10.75. So pOH is 14 minus pH, which is 14 minus 10.75. 14 minus 10.75 is 3.25. Okay, so this is 3.25. And then if we need to find whether it's acidic or basic, this one is greater than pH 7, so this solution is basic. Now let's use pH to find concentration of the acid. Concentration of acid equals to, in fact, let me just do this. pH equals to negative log concentration of the acid. Okay, so concentration of the acid will be equal to 10 to the power negative log of the pH, or antilog of the pH. So in this case is the antilog of negative 10.75, and my answer is, so let me see, antilog of negative 10.75. So I'm getting it to be 1.7, or let me say just 1.8 times 10 to the power negative 11. Okay, that's the concentration of the acid. 1.8 times 10 to the power negative 11. Okay, pOH equals to negative log of concentration of the base. So concentration of the base can be gotten by saying antilog of pOH, which of course is antilog of negative 3.25, because our pOH is right here. So I'll come back here, negative 3.25. So I'm getting 5.6 times 10 to the power minus 4. So this is 5.6 times 10 to the power minus 4. Another way to get it is to say concentration of the acid equals to 1 times 10 to the power minus 14 divided by concentration of the base. This is just another formula. Okay, like if you rewrite this formula right there, you're gonna get this. So I'm gonna prove that my answer that I got before is correct. So concentration of the base was initially was okay, what do we need here? Let's see. I think we need concentration of the base, so I should put here OH minus, and this should be H plus. Okay, So the concentration of the acid in our table is 1.8 times 10 to the power minus 11. So let's say 1.8 exponent minus 11. So 1.0 exponent minus 14 divided by 1.8 exponent minus 11. So I'm getting concentration to be 5.6 times 10 to the power minus 4. So the method is correct. Okay. Okay. So on part D, you are given pOH to be equal to 5. So we need pH, H, and OH. Given this, pH will be equal to 14 minus pOH. The pH is 14 minus 5. Obviously, that's 9. Okay. So the pH is 9. So we can come on our table and say this is 9. And then if it's 9, then it's basic because this is greater than pH 7. Alright. So next, we find concentration of the acid and concentration of the base. So if I am to find concentration of the acid, it's going to be antilog of negative of pH, which is antilog negative 9. So let me see if I can do antilog of negative 9. The answer is 1 times 10 to the power minus 9. To find concentration of the base is antilog of pOH. Of course, pOH is 5, so negative 5. So antilog of negative 5. The answer is 1 times 10 to the power negative 5. Okay. Let me try again. Antilog negative 5. Okay. Yeah.